So tell me, if you will, here, and this is, once again, this is a kind of a, because physics is a science and we're dealing with quantities that are measured, we have to know how to handle that. So what if we measured something, let's say we're measuring a distance and we get an answer of, say we get an answer of 100 centimeters. Okay, how many significant digits are there? You would say 1, although it's a little bit ambiguous, isn't it? Right? 1 because the trailing zeros are presumably not, they're just holding place, right? But it could be that we actually measured it to be 100. It's a little bit ambiguous, isn't it? There is a way that we're not going to do because Moodle doesn't like it, but there is a way that you could change this very slightly to indicate that it really is 3. What is that, do you know?
The decimal after the 100.
Okay, you could put a decimal after the 100, not adding a 0, but that tells you that everything up to that place right there is actually measured. Okay? Once again, in Moodle, it's not going to like that. So we're going to have to live with that ambiguity. But the context of the problem I give you should tell you what's, what is it? Is it 1 or 2 or 3? What if there were 2 measured places? You're kind of stuck, aren't you? Right? You see that if we measured this to the tens place, how would you know? You can't put a decimal there, right? It is ambiguous. Suggestions?
Scientific notation.
Okay. One thing we could do that always works is we could write this in terms of scientific notation, right? So you guys have all, raise your hand if you've done scientific notation before. Everybody's done scientific notation. So what are the rules for scientific notation? We write it, a scientific notation number, we would write kind of bad color. We'd write it in the form A times 10 to the B, let's say. What are the characteristics of A and B in this case? What do you know about A? Richard, what do you know?
It's got to be less than 10.
It's got to be less than 10 and greater than
0.
well, actually, greater than or equal to 1, right? It's got to, does that make sense? Okay. So A greater than or equal to 1 and less than 10. And what about B? What about B? Any criteria that you... Okay, could be a whole number.
Greater than.
Okay, not necessarily. It could be a whole number, but we could even, we don't need to restrict ourselves to whole numbers. What's the word we're looking for here?
Fractional numbers.
Well, integer. That's what we want. We want it to be an integer, right? And so B is an integer. Now remind us really quick, that's a subset of real numbers. What do the integers look like? Where are they on a number line? There's an easy way to think about integers. What are they? They're really just positive and negative whole numbers, right? But they're just all the hash marks on a number line, on a standard number line. Where do we put the hash marks? Well, 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, etc., right? So those are the integers, okay? So those are the criteria for scientific notation. Okay, now let's talk about how we use scientific notation. So what if we want to take something like, for example, let's start with a little easier one that's maybe, 100, well, we'll do that one. So written in scientific notation, what would that be then? Okay, good. It's going to be 1 times 10 to the second. How do we get that? Well, right now the decimal point sits here, right? So what's our trick for writing scientific notation? We want to move the decimal point until A fits the criteria, where it's greater than or equal to 1 and less than 10, right? So in this case, that implies we're going to move it to the left by 2 places. Make sense? If we're moving it to the left, now think about it this way. If we're moving it, we have to keep things in balance. If we're moving it to the left, this number is decreasing by 2 factors of 10, right? Because a 1 is a lot smaller than 100, right? So then we have to multiply it by a power of 10 that is increased by positive 2 to keep things balanced. Does that make sense? Let's try another one. What if you had something like 1,400, okay, 1,400. Yes, ma'am.
For the first one,
Mhm.
would it to mark the appreciation
Okay, if it were 3, you're right, if it were. If it were 1, we'd leave it like that, but that's a good point. What if it truly were 3? Then say we've measured it out to 3 places. What would I have to do here then? I would have to have 1.00, so that number has 3 sig figs represented. Okay. What if we had measured it to the tens place? What about then? 1.0. Okay. So let's say we've measured this one only to the hundredths place. What's this going to equal in terms of scientific notation then? You got to start here. How far are we going to move the decimal? 3 places, which is going to make it 1.4 times 10 to the 3, right? Make sense? What if this had actually been measured all the way out to the ones, which would be a kind of a coincidental occurrence that it happened to fall right on 1,400, but what if it did? What would we have to do?
4 zeros.
Good, we'd have to add a couple zeros right there, wouldn't we? Okay, thanks, sir. Okay. What about then, let's go the other direction. What if we had something like, let's say we had something like that. How many sig figs there?
3.
3. Okay, good. The first 2 are just holding a place, aren't they? Right? Zeros that come, if you're writing a decimal number, the zeros that are in front of the first digit are always just holding a place. What if I did that? Okay, then that's 4. Then that implies that we actually measured this out to that digit and it was a 0, right? So how would we write that with scientific notation then?
2.570.
Okay, good. So we start with the decimal there. Now we've got to move it 1, 2, 3 places to the right. So we end up with 2.570 times 10 to the what?
Negative.
Okay, negative. When we scoot the decimal, when we change from a 0.00257 to 2.570, what have we done? Well, we've increased that number a lot. We've multiplied that number by a factor of 10 to the 3 to make it that much bigger, right? Everybody agree? So we got to keep things even. We got to keep things balanced and multiply by 10 to the minus 3 to negate that change. Okay, make sense? Okay, that's it, right? Okay, so we got scientific notation. You get a little practice with that. Just, little practice recognizing, converting from decimals to scientific notation and vice versa. Standard notation to scientific notation. Now, what about something like this? Now let's talk about how we deal with measured quantities. And we're not even really talking any physics yet. We're just how do we handle these quantities. Let's say that we measure, I'll pull up a sample problem. Let's say we do something like this. Okay, let's say we add up something like that. So we make these measurements: 3.8 grams, 0.56 grams, 9.711 grams, and 5.9 grams. Those are all measured quantities. And we want to find a sum of all of those measurements. Okay, what do we do? Suggestions.
Plug them into your calculator.
Okay, let's plug them in our calculator. That's a good idea. Let's try that. Okay, so if I do 3.8 plus 0.56 plus 9.711 plus 5.9, I get the answer 19.971. Is that the correct answer?
No.
Okay, it's not. I mean, it is and it isn't, right? It is what those numbers add up to, but what's the issue here? When we're adding up measurements, what do we do? Okay, here, somebody, you ready to go? Somebody raise your hand. Nick, what do we do?
The answer has to be like the amount of significant digits most. It has to be in the same, has to have the same amount of significant digits of all previous numbers. Has to have the number with the most. Like 9.711, right? That's not 4.
Okay, has 4, right?
Yeah.
Okay.
The least.
Not, okay, now, it would be the least, except with addition, it's not even really a significant figure issue. Okay, yeah, we're gonna keep, when you're adding or subtracting a bunch of measured quantities, right? What you do is you add it up and you can only retain the digit, the least precise digit. Does that make sense? So if you look at these, let's see, it looks like this one is measured to 1/10 of a gram, to 100th of a gram, to 1,000th of a gram, and to 1/10 of a gram. Well, what's the least precise digit up there? The least precise would be 1/10 of a gram, everybody agree? This is only measured to within 1/10 of a gram, and so is that. These other ones are measured to with greater precision, right? Does that make sense? But these ones, it would be guesswork to go beyond 1/10 of a gram, right? So we can't do that. We can only go as far as the least precise measurement. So when we add these things up, this is the answer we get, but where do we have to round that? Yeah, we got to round it back to the tenths column, okay? And so what do we end up with? 20, okay? 20.0, right. So that should be the correct answer. 20.0, and then we're just filling in the blanks so the unit's already there, right, in Moodle. Okay, does that make sense? Okay. Same thing for subtracting, right? So we're just going to line them up and only keep the least precise column. Okay, what about multiplying? So what if we do something like this? Multiplying or dividing. Okay, so should be parentheses right here. Let me fix that. These are some old questions. Oops. There, now it's fixed. Okay, so what about that one? We've got negative 80,322 centimeters times negative 401.8 centimeters. Okay, what would the units be, by the way?
Centimeters squared.
Yeah, centimeters squared, or square centimeters. Okay, how do we deal with the number of significant figures here? Okay, when we're multiplying, good. So now we'll pull out the calculator again. Let's first of all let's simplify the product. So we get negative 80,322 times negative 401.8. Okay, and we get a numerical answer of that, right? Big answer. Okay. But when we're multiplying, we've got to go back and just count the number of sig figs that show up in each measurement, and we can only retain the least number of sig figs in any measurement. How many does this have? 5. How about this guy? 4. So we only get to keep 4. So we got to round this back to 4 places. So what's that going to be? If I go to 4 places, that's 3, 2, 2, 7. The next digit's a 3. So what's that mean? Okay, so then that rounds down, so it's just that rounds to 32270000, right? Okay? One more zero. Okay, and we need units, don't we? Okay, so we don't want a decimal there, right? So we should get that. Oh, no, centimeter squared. Whoops, screwed up. Didn't include the correct units. Whoops. Okay, so centimeters. Let's go up here. Centimeters squared. How's that? There we go. Okay? Make sense? Okay. That is, I think what I'm going to let you do then, first assignment's no big deal. I want you to just kind of practice getting used to Moodle. That's what this is as much as anything. So get a Chromebook, go into physics, go to Unit 1 practice, and, oops, I got to open that up, don't I? Hang on here. Okay. Okay, got the first two assignments. And then all you're going to do with these, if you click on one of those, it's going to ask you, I've already started this one, you won't have it, it'll say attempt quiz, and you'll click on that, and then when you do, something like this will happen. You'll see the quiz, you can kind of see the structure of the quiz here on the left. You got 2 ordering numbers questions, 2 arithmetic with scientific notation, or 4 of those, and then 4 conversion between scientific and standard notation on that first assignment. So just 10 problems total. Okay, next one is just going to be some stuff where you're doing arithmetic with measurements. Okay, so just try this out. This isn't really very, it's just kind of a warm-up almost in a way, but get used to the format a little bit. Yes, ma'am. Yeah. Let's get you in there. So, okay. Oops.
Was there a reading assignment Thursday and Friday?
Yeah, but you can still do it. It's no big deal. If you go to the OpenStax textbook, this is kind of cool. Just takes a second to load here. Okay, this is kind of cool. If you go to the contents, we're just looking at everything up through 1.3. We're not going to do 1.4. So that's the stuff to look at. Okay? All right. No Nick today? Is he here?
Nick,
Other Nick? You went home? Okay.